Hello friends, today we are going to solve a problem called diameter of a binary tree. So basically what is the diameter of a binary tree? Suppose you are given a binary tree like this, okay? Then you have to find the farthest point from a node to another node. Like here, the farthest point from this node is 1, 2, 3, 4, 5, 6, 7. So this is the farthest point from this node. So the diameter of this will be 7. Okay. So you may think that I will count the left part of the nodes, and then I will count the right part of the node, and then I will add that. But it will not work in every scenarios. Like if I take another scenario like this. Okay. Like this. In this you cannot simply add the left part and the right part and it will result into the diameter, because the diameter will be like 1, 2, 3, 4, 5, 6, 7. The diameter is 7. But if you do it by simple method like 1, 2, 3, 4, 5, 6, it will result into 6. Okay, for this it will be 6, but here that it is 7, so actual diameter is 7. Okay, so one may think that starting from the top, I will count the maximum. I will count the at the left part, I will count the longest nodes part, like here 1, 2, 3, 4. For this the longest part is 4. Okay, left is equal to 4, and for the right the longest part is 1. So basically it will be like 1, 2, 3, 4, 5. So the diameter for this is actually 5. Now coming to here, the diameter from this is 1, 2, 3, 4, 5, 6, 7. For this the diameter is 7. For this the diameter is 3. Similarly for this the diameter is 2, and for this diameter is 1. And for this similarly we can do recursively for all of them, and maintaining a variable called max, which will store the maximum value. So until now the maximum value stored is 7. Okay, so this method will work fine, but it will take O of n square timing. Okay, so this is not much efficient, so we want a efficient solution. Okay, so the efficient solution is like suppose with the same binary tree, what I will do, starting from here, since if it is null, like I will write the statement, if root is equal to null, what I will do, I will just return 0. Okay, so its left part is 0, so I will return 0, and the right part is 0, so I will return 0. But this is 1. This node is not counted until now, so I will count this as 1. So left will become 1. Okay, and in the same way plus 1, right will be 1. Okay, so it is like L is equal to 1 plus count, which is our function, root to the left. For the right it is also 1 plus count root right. Okay, now what is the diameter for this node, considering this is a root? Okay, so for this the diameter is like L plus R minus 1. Why minus 1? Because this node is counted in left also and right also, so we have to exclude 1. So the diameter is 1 plus 1 minus 1, which is 1. So our max will become 1, since max is a variable which I have initialized with 0. Okay, so now max becomes 1. So I will write this statement like, if L plus R minus 1 is greater than max, max is equal to L plus R minus 1. Okay, then I will return the longest of the left part or the right part. Since both of them is same, which is 1, so I will return 1. So the longest part of the left of this node is 1, so it will become, so its left will become 1 plus the returning value, which is also 1, so it will become 1. And for this, right is equal to 1 plus 0, since there is no node, so it will be returning 0. So L plus R will become 2 plus 0 minus 1, which 2 plus 1 minus 1, which results into 2. So our max will be updated and max will becomes 2. Okay, so what I'm doing, I'm just return max of L comma R. Okay, so this was actually our function, and count node star root. So this was our function. So in the same way, I will return 2 since it is the maximum. So for this, the left is 1 plus the returning value, which is 2, and for this, the right is 0 plus 1. Since there is no node, so it will return 0, and I will count this node also, so it will be 1. So 3 plus 1 4 minus this node will be 3 plus 1 4 3, so max will be updated and it will be 3. In the same way, it will return 3, so its left will become L is equal to 1 plus 3, and for the right, I will go down to the here. For this, the left is 1, right is 1, I will return 1 to the here. So similarly it will return 2, similarly it will return 3. Okay, so its right will become 1 plus 3, so it will become 4, and this will become 4. So 4 plus 4 8 minus 1 7, so our maximum will be 7. Then I will return the maximum of both of them, since both of them are 4, so I will return simply 4. For this, the left node will become 1 plus 4, and the right will return 0, so it will right becomes 0 plus 1, so it will become, so the diameter will become, for this is 4 plus 1 5 minus 4 plus 1 5 plus 1 6 minus 1, so it will be 5, but the maximum is 7, so I will not update max, and hence the diameter of the tree is 7. Hence we have calculated the diameter of the tree, which is in the solution of O of n. So thank you. If you like this video, you can subscribe my channel. If you have a better idea, then you can submit your code in a comment section. Okay, so thank you.